Hello, class 8 boys. Today we will discuss on some more application of standard identities. Okay, so let us take one example from exercise 10.5. Okay, before we do that, let us quickly revise the formulas of standard identities, whatever we have discussed so far. So the first formula is a plus b whole square is equal to a square plus b square plus 2ab. The second formula is a minus b whole square is equal to a square plus b square minus 2ab. The third formula is a plus b multiplied by a minus b is equal to a square minus b square. And the fourth one, which we discussed in yesterday's class, is um, x plus a multiplied by x uh, plus b is equal to x square plus a plus b x plus a b. Okay, now the reason why I'm writing these formulas again and again is that these formulas are very important. You should be knowing these formulas. These formulas are very important whenever you deal with numerical problems in physics, in chemistry, or in mathematics in high level. These formulas are very beneficial. You will be using these formulas left and right, so you should be knowing this formula. That is the reason why I write down these formulas again and again, so that you understand the importance of these formulas, okay, which are also known as a standard identities. Okay, so these four formulas from standard identities. Okay, now let us quickly take one example. Let us discuss question number 6 Roman 2. Okay, question number 6 Roman 2. Okay, I'll read out the question first. Question number 6: using the identity a square minus b square is equal to a plus b multiplied by a minus b, find 2.05 whole square minus 0.95. That means the question says using the identity, this one, a square minus b square is equal to a plus b multiplied by a minus b. You need to find the value of 2.05 whole square minus 0.95 whole square. Okay, we see that we have written the identity in the reverse order. A plus b multiplied by a minus b is equal to a square minus b square, but this, the converse is also the true. That means the reverse also can be written: a square minus b square is equal to a plus b multiplied by a minus b. Okay, so let us see how will we use this standard identity to find the value of 2.05 whole square minus 0.95 whole square. Okay, now this takes our value of a, and 0.59 takes the value of b. So this is our a square, b square. So a square minus b square is equal to a plus b multiplied by a minus b. Okay, so this means this is 2.05 whole square minus 0.95 whole square. So this is equal to a square minus b square is equal to a plus b. This is our a plus b multiplied by a minus b. 2.05 minus 0.95. So this gives us 2.05 plus 0.95. Let us work it out in the rough. 2.05, we are adding 0.95. Okay, 5 plus 5 10, carry over 1, 9 plus 1 10, 0 carry over 1, so 2 plus 1 3, so 3.00, or simply we can write 3 multiplied by 2.05 minus 0.95. 2.05 minus 0.95. Okay, let us subtract this. 5 minus 5 is 0, this becomes 1, carry over 1, this becomes 10, 10 minus 9 is 1 point, and this becomes 1, 1.10. So this means it is 3 into 1.1. Okay, so let us multiply this. So 1.1 multiplied by 3, 3 ones are 3, 3 ones are 3, decimal point after one number 3.3. So our final answer for this question would be 3.3. Okay, I hope this sum is clear to you. This was a very simple straightforward sum. A square minus b square is equal to a plus b multiplied by a minus b. 3 into 1.10, 3.3. Okay, now let us take a similar type of question. Question number 7. Question number 7. The question says simplify the following. Simplify the following. Simplify the following. Okay, the question is 7 by 2a minus 5 by 2b whole square minus 5 by 2a minus 7 by 2b whole square. Okay, now we need to simplify this. Okay, before we simplify, let us write down this in a more simpler fashion. Okay, so what is this? Is 7a by 2 minus 5b by 2 whole square minus this is 5a by 2 minus 7b by 2 whole square. Okay, now this is in the form of a minus b whole square minus again a minus b whole square. So what we'll do, we will expand this separately, we'll expand this separately, and then we'll try to simplify this. Okay, so this is in the form of a minus b whole square. So let us go back to our formula. A minus b whole square is equal to a square plus b square minus 2ab. So this is our a, this is our b. Okay, so a minus b whole square is equal to a square plus b square minus 2ab. So let us expand this. So this is 7a by 2 a square plus b square minus 2 into a into b. So what's this? This is the expansion of the first bracket only. Okay, minus, now the same thing, a minus b whole square. So this is 5a by 2 whole square plus 7b by 2 whole square minus 2 into a into b. Okay, so this is the expansion of the second bracket. Okay, now let us continue. Okay, here we go. Right, so 7a by 2 whole square, this would mean it is 49a square by 4 plus 5b by 2 whole square would mean 25b square by 4 minus, okay, now again I'll just quickly take you here. Okay, minus, okay, what are the cancelable term? The 2 and the 2 will cancel out each other. So what is left over here? 7 5 is 35, 35ab divided by 2. So this would give us 35ab divided by 2, 35ab divided by 2. Okay, minus, okay, now this gives us 25a square by 4 plus 49b square by 4 minus, okay, let me take you to this page once again. Okay, here we go. So what do we have here? The 2 and the 2 will get cancelled here. So what is left over? 7 5 is 35 ab by 2, 35 ab by 2. So this gives us 35 ab by 2. Okay, now we will simply open the bracket. 49a square by 4 plus 25b square by 4 minus 35ab by 2. Now since there's a minus, we multiply the minus sign inside the bracket. So minus into plus, minus 25a square by 4 minus into plus, minus 49b square by 4, and then minus into minus, this gives us plus 35ab by 2. Okay, now 35ab by 2 with the minus sign, 35ab by 2 with the plus sign, so both of these will cancel out each other. So what are we left with? 49a square by 4 plus 25b square by 4 minus 25a square by 4 minus 49b square by 4. Okay, now what we will do, we will write down the like terms together. That means the 49 and the 49 together, and the 25 and the 25 together. So this would mean 49a square by 4 minus 49b square by 4. We have written the 49 and the 49 together. Then again 25b square by 4 minus 25a square by 4. Okay, now in these two terms, what is common? 49 by 4, 49 by 4. So we take 49 by 4 common. So what is left over here? So a square minus b square. Okay, now here what is common? 25 by 4, 25 by 4 is common. So what is left over here? b square minus a square. So you can leave the answer here. Well, there are many forms in which you can express this too. Okay, but at the moment we'll leave it up to here. Okay, so you can leave the answer here, because if you want to simplify it further, again a square minus b square can be written as a plus b into a minus b. This also can be written as b plus ab minus a, and then we can simplify further. Okay, but at this moment we'll just leave it up till here. So this, after simplifying this, we will get this as our final answer. Okay, so we'll just leave it up to here. Okay, now let us take one more example. Question number 8. Okay, let us see how do we go about question number 8. Question number 8 Roman 2. Question number 8 says show that, that is the prove that question. Okay, so question number 8 is show that, so that I'll solve question number Roman 2 7 question number 8 Roman 2. Okay, 3p by 7 minus 7q by 6 whole square plus pq is equal to 9 by 49 p square plus 49 by 36 q square. Okay, that means you need to show that after solving this part you will get 9 by 49 p square plus 49 by 36 q square. Okay, so as we do in rest all the question of prove that question, we'll start from the left hand side, we'll start solving, and let's see whether we arrive at the right hand side or not. Okay, so we take the left hand side. So what is our left hand side? 3p by 7 minus 7q by 6 whole square plus pq. Okay, now let us try to solve this. We'll expand this. This is in the form of a minus b whole square. Okay, this will leave it as it is for the time being. Let us see what will we get after expanding this. So this is in the form of a minus b whole square. So this is 3p by 7 whole square a square plus b square minus 2 into a into b. So this much is the expansion of the bracket, then we have a plus pq here. Okay, now what does this give us? This square is for all the bracketed term, so 3 square is 9, p square is p square divided by 49 plus 49 q square by 36 minus, okay, the 7 and the 7 will cancel out each other. 2 1s are 2, 2 3s are 6, 3 1s are 3, 3 1s are 3. So what is left over here? P into Q, PQ, and then we have a plus PQ here. Okay, so minus PQ and plus PQ will cancel out each other. So what are we left at the end? We are left with 9P square by 49 plus 49 Q square by 36. So if you see, this is exactly what we are looking for. So which is equal to our right hand side. So this is easily proved. Okay, so we started with the left hand side, we expanded the bracket, and then we have arrived at the right hand side. 9p square by 49 plus 49q square by 36. 9p square by 49 plus 49 q square by 36. That is our right hand side. Okay, so this is question number 8 Roman 2. Okay, let us take up one more example. Question number 8 Roman 3, and then we'll go to your assignment, today's assignment. Okay, so let us see, let us try to solve question number 8 Roman 3. Okay, question number 8 Roman 3. Okay, question number 8, again it is the same type of question. Show that question, show that. Okay, and what is the question? The question is P minus Q multiplied by P plus Q plus Q minus R multiplied by Q plus R plus R minus P multiplied by R plus P is equal to 0. Okay, so this is our question. We need to show that P minus Q into P plus Q minus R into Q plus R minus P into R plus P is equal to 0. Okay, so we will begin from the left hand side. We'll try solving from the left hand side, and then we'll try to arrive at our answer, which is equal to 0. Okay, so let us see. So we begin with the left hand side. So what is our left hand side? Our left hand side is P minus Q multiplied by P plus Q plus Q minus R multiplied by Q plus R minus P multiplied by R plus P. Okay, now if you closely observe, this is exactly in a formula: P minus Q, P plus Q. Similarly, Q minus R, Q plus R. Similarly, R minus P, R plus P. So this is in the form of A square minus B square. So P minus Q into P plus Q is nothing but P square minus Q square. Then we have the plus here. Now what is this? Q minus R, Q plus R. This is in the form of Q square minus R square. The plus comes here. Now the last two brackets, R minus P into R plus P. This is in the form of R square minus P square. Okay, now let us see what do we get after we simplify. P square, and we have a minus P square. So plus P square minus P square will cancel out each other. We have a minus Q square plus Q square. This also cancels out each other. Then we have a minus R square and a plus R square. This also cancels out each other. So what are we left with? Nothing. That means we are left with a 0. And what is 0? 0 is nothing but our right hand side. 0 is nothing but our right hand side. So LHS, the left hand side, is equal to the right hand side is equal to 0. So what we can say, hence we have proved whatever we were asked to in question number 8 Roman 2. Okay, I hope this sum is clear to you. Actually, this sum was a very simple one. Okay, it is already given in perfect order of a square minus b square form. Everything cancels out, and then you automatically get the right hand side. Okay, now after this, let us see what would be your questions for your home assignment. Okay, so we begin from question number, okay, your homework, question number 6 Roman 1 and question number 6 Roman 3. Then we have question number 7 Roman 1 and question number 7 Roman 3. Then we have question number 8 Roman 1. 8 Roman 2 and 3 already I have done for you. So question number 8 Roman 1. So these questions are all similar type of question. Okay, before I leave you, let us quickly see how do you go about your assignment. Okay, question number 6 Roman 1. Okay, if I am to briefly discuss question number 6 Roman 1. So we have 53 square minus 47 square. Okay, how will you solve it? This is in the form of a squared minus b squared. So what is a squared minus b squared? A plus b into a minus b. Okay, so a squared minus b squared is equal to a plus b into a minus b. That means 53 plus 47 multiplied by 53 minus 47. So this shouldn't be a problem. Okay, question number 6 Roman 3. Question number 6 Roman 3 is 14.3 whole square minus 5.7 whole square. Now again this is in the form of a square minus b square. So a square minus b square is again a plus b into a minus b. That means 14.3 plus 5.7 multiplied by 14.3 minus 5.7. Okay, so the same process. So in both these questions, what formula are you using? A square minus b square is equal to a plus b multiplied by a minus b. Okay, question number 7 Roman 1. Question number 7 Roman 1, if I am to write down the question for you, 2x plus 5y whole square plus 2x minus 5y whole square. Question number 7 is simplify the following. So you have to simplify the following. So do one thing, take the formula a plus b whole square, expand this, then give a plus, and then a minus b whole square, expand this, and then see what are the terms that will cancel out. So whatever is remaining, that will be your simplified answer. Okay, expand this using the formula for a plus b whole square, and expand this bracket using the formula for a minus b whole square, and then add it up and then see what do you get. Some of the terms will get cancelled, so whatever you are left over, that will be your answer. Okay, then we have 7 Roman 3. Question number 7 Roman 3. Okay, p square minus q square r whole square plus 2p square q square r. Okay, so this is also similar type of question. What you do, you use the formula for a minus b whole square, you expand the bracket, then you write down the plus 2p square q square r and see whether this cancels out with any of the terms, and whatever is left over, that will be answer. Okay, so this you need to expand using the formula a minus b whole square. Your a will be p square and your b will be q square q. So use the formula a minus b whole square. Whatever answer you get, you try to simplify with this. Okay, then you have question number 8. Question number 8 Roman 1. Question number 8 is show that prove that 4x plus 7y whole square minus 4x minus 7y whole square is equal to 112 xy. Okay, so you begin from the left hand side, you expand 4x plus 7y whole square using the formula for a plus b whole square, then a minus, then expand this 4x minus 7y whole square by using the formula a minus b whole square, expand, and then be careful, there is a negative sign here, so don't forget to use the bracket here whenever you expanding this, because if you have a negative sign, that means all the terms inside the bracket will change. Okay, the sign of all the terms will change, so be very careful with this minus sign. Put a bracket and then expand this, and then some of the terms will cancel, so you will be just left out with 112 xy. Okay, so you need to add up one term from here, one term from here, and you will add up to 112 xy. Okay, so that will give you the RHS. Okay, so your assignment for today will be question number 6 Roman 1 and 3, question number 7 Roman 1 and 3, and question number 8 Roman 1, and all these questions are from exercise 10.5, which is on page number 207. Okay, so that's all for me today, and please take care of yourself, stay safe and stay healthy. Goodbye.